All right, let's suppose we are doing some hypothesis tests with two proportions. So remember that means we have two distinct populations. We're asking some sort of categorical, most likely a yes/no type of question, and looking at the proportion of whatever we deem to be a success for each of those populations, right? The samples that we get from those populations, and then comparing. So the first part of this, if we're actually running a hypothesis test, and for this particular problem, the description is provided not here, but below or above the problem. So the first thing we would want to do is make sure we have large enough samples in order to proceed. So in this case, that usually means saying N1 P1 hat is that at least 10. Now what that means, since we're using P1 hat, that means we're using the sample data, and really this is saying sample successes. So how many successes do we have? For this, that means saying yes to being in college-owned housing. So in this case, our first SRS had 37 students who said yes, they do live in college-owned housing. And these were the Longwood University students. So that's at least 10, so we're in good shape. For N1, 1 minus P1 hat, well, that just means how many people do not live in college-owned housing. So our 37 people came from an SRS of size 55. So 55 minus those 37 means we have 18 people, and that also is at least 10. So far, sample 1 looked good. We had at least 10 successes, at least 10 failures. If we look at sample 2, then we'd say, okay, cool. These are students from VCU. So 14 of them reported living in college-owned housing. Again, that's at least 10, so we're good. And then if we want to know how many do not live in college-owned housing, yeah, again, this is the formula, but if the problem's already providing us number of successes and the sample size, we don't actually need to calculate that formula. We can just think about it as number of successes, number of failures. So our number of failures are, let's see, 40 VCU students, 14 of which live in college-owned housing, so 26 of them do not. Okay, 26 is at least 10. So it looks like sample 2 also is in good shape. So first of all, that's before we proceed. We say, well, did we take random samples? Yes. And do we take a large enough random sample so that we get 10 successes, 10 failures from each? And yes, so our samples are definitely large enough to proceed. So that's a good sign. So then let's actually go to set up our test. As we've done before, we want to say, well, what is my null hypothesis? What's my alternative hypothesis? So our null in this case, it's not working. Our null in this case is that the proportions of students in college-owned housing is the same, right? So there are a couple ways to say that, but one way to say it is that P1 is equal to P2. Another way to say that is that P1 minus P2 is equal to 0. It's another way to frame that, right? That basically that there's no difference in the two proportions. And if you want to use something other than 1 and 2, if you want to say like L for Longwood and V for VCU or something like that, totally fine, if that'll help you. So the alternative hypothesis, now remember, this is not a result of our samples. Usually these hypotheses show up before we take samples. So we would want to think, is there anything in the wording of the problem? So the wording of the problem here says, run a hypothesis test at the 1% significance level. Okay, that's actually telling us alpha. So alpha is 1% or 0.01. So run a hypothesis test at the 1% significance level to determine whether there's a difference in proportions. Okay, whether there is a difference does not say that we think Longwood has more or VCU has more. So that just means that P1 is not equal to P2, or that, right, if we kind of want to reframe it to think about it like P1 minus P2 is something other than 0, right? Maybe not, maybe greater than 0, maybe less than 0, but we don't have anything to clue us in one way or another. So there's our hypothesis test. Now, we could find our test statistic and kind of run through everything here, but instead, I'm going to show us how we would do this in our TI 83 or 84 calculators. So we're going to go to Stat, and then over to Tests. Right. And when we do that, we get a long list of tests and intervals. Well, here we want a hypothesis test, so we want to make sure it says test. The other piece is that we see two proportions. So we have two sample and two proportions. So we definitely want to have one that says two prop, right? And then in that list, you're going to see that there's really only one choice for this, which is to have a z test. We know that for means, sometimes we use a t-test, right? So you have to choose between z and t. That's not the case with proportions. We're always using z for proportions. So we proceed with that test, and it's going to ask some pretty basic stuff. So it's going to say, what's x1 and n1? What's x2 and n2? And the good news is we actually already did some of that up here, right? X1 is just the number of successes for sample 1. Well, that was 37. And then N1 is just that sample size, which was 55. X2, that's the number of successes for sample 2, so that was 14. Out of how many? So how big was our sample? That was 40. So putting in some pretty basic information, and then we want to know what is our alternative hypothesis, right? The null is always assumed that these two are equal, so unless we say otherwise. So P1, we have this option, right? Not equal to P2, less than P2, greater than P2. So we're going to select the first one, right? The one that aligns with our null here. So not equal to P2, and if we calculate that, the most important thing once we calculate that is, hey, what is our p-value? So our p-value ends up being 0.00184, right? And that decimal keeps on going. But we see that that's a very, very small p-value, meaning that, well, first of all, we would want to compare it to alpha. That's definitely less than alpha, even though alpha was pretty small itself, 0.01. So what we're saying is this is the likelihood, right? This 0.00184 or 0.184%. That's the likelihood of getting sample results like ours if the null is true. Okay, well that's very, very unlikely to occur, meaning maybe the null isn't true, right? This is a case, so P is less than alpha. That's a case where we say, okay, we're going to reject the null hypothesis. So we have reason to believe we should reject the null. It's always a good idea to put that in context, right? And say, well, what does that mean? So we're going to reject the null hypothesis, which said the proportion of students living in college-owned housing was the same for both Longwood and VCU, right? So we have reason to believe that there is some difference in those proportions. We're not claiming one is greater than the other, but just some difference in the two.